Welcome to today's video. We'll start with section P-2, which talks about exponents and scientific notation. First thing we'll do is just review the properties of exponents. The first one is the negative exponent rule. Basically, if you have a negative exponent, for example, x to the negative first, that is the same as saying 1 over x. So if you had y to the negative third, that would be the same as saying 1 over y to the third. So basically, anytime you have a negative exponent, it goes into the denominator of the fraction to make it positive. So if I had 3x to the negative second, it would be the same as saying 3 over x to the second. So I move that negative exponent to the bottom of the fraction to make it positive. The zero exponent rule basically says that anything to the 0 power, like 5 to the 0, is equal to 1. So anything to 0 power, x to 0, is equal to 1. The product rule of exponents basically says if you multiply the same term with exponents, that you can add the exponents. So x squared times x to the third, that becomes x to the 2 plus 3, which is x to the 5th. The power rule, when you raise a term with exponents to a power, that means you're going to multiply the exponent. So x to squared to the third power is x to the 2 times 3, which is x to the 6th. The quotient rule, when you divide the same variable with exponents, that you subtract the exponents, so it becomes x to the 4th here. Whenever you have products raised to a power, for example 3x squared y to the third, and I want to raise it to the third power, remember that you're going to have to distribute this exponent to each term, so it becomes 3 to the third, x squared to the third power, which basically, as we'll see, means you're going to multiply, and y third to the third power. So basically 3 to the third is 27, x squared to the third is x to the 6th, and y to the third raised to the third power is y to the 9th, because you multiply. Same things happens if you divide terms with exponents. So for example, if I have 10 x squared y to the 5th over over x and then y. Well, if I'm raising that to the second power, I have to just basically raise each term to the second power. So not only do I have to raise 10 to the second, x squared to the second, and y to the 5th to the second, but I also have to raise x to the second and y to the second. Now I'll show you in a second, in a little bit, the easiest way to do a problem like that. 100 x to the 4th, y to the 10th, over x squared, y squared, and then you can subtract. So you get 100 x squared, y to the 8th. And that would be your final answer. All right, so simplifying exponential expressions. So the first one here is an example of raising a product to a power. So remember, we got to distribute the 3 in. So we have negative 3 to the third, x to the 4th to the third, and y to the 5th to the third. Negative 3 to the third is negative 27. X to the fourth to the third is x to the 12th. And then this becomes y to the 15th. Something like this, where there's division, we can divide each one separately. So negative 35 divided by 5 is negative 7. X squared divided by x to the 6th. Well, remember that you subtract, so 2 minus 6 gives you negative 4. And y to the 4th minus, or y to the 4th over y to the negative 8th. 4 minus the negative 8 is the same as 4 plus 8, so it becomes y to the 12th. Now notice you have a negative exponent here, so we're going to move that to the bottom of the fraction. The negative 7 is not a negative exponent, it's a negative number, so it stays. You're going to move that to the bottom to make it positive, because all exponents must be positive in your final answer. Here, 4x squared over y raised to the negative third, so we're going to raise each term to the negative third power. That becomes 4 to the negative third, x to the negative sixth over y to the negative third. To make them positive, we're going to switch them in the fraction. So this becomes y to the third on top. 4 to the negative third becomes 64. And that's going to go to the bottom to make it positive. And x to the sixth goes to the bottom to make it positive. Something like this here. We got to distribute first. 3 to the third, x to the third, y to the sixth when we multiply. And then times x to the third, y to the fourth. So 3 to the third is 27. X to the third times x to the third, we add and get x to the sixth. Y to the sixth times y to the fourth, you add and get y to the 10th. And that is our final answer. Scientific notation. Remember, scientific notation is when you have a product where it's times 10 to a power. A has to be between 1 and 10. So, for example, 4.3 times 10 to the fourth. That is scientific notation because the A term here is between 1 and 10. When n is positive, for example, 4.3 times 10 to the fourth, you're going to move the decimal to the right. So it'll look something like this. 2, 3, 4. So you're going to move it 4 spaces. So you move it 1, and then you have to add zeros right there. So it becomes 4,000, actually 43,000. When n is negative, you're going to move the decimal to the left. So for example, 4.3 times 10 to the negative fourth, we would take the 4.3 and we move the decimal to the left. 2, 3, 4, and you put zeros there. So it's 0.00043. Now, some rules here. Converting from decimal notation to scientific notation. So if it's a decimal, for example, 56 million. You determine what the A term is by moving the decimal point to obtain a number whose absolute value is between 1 and 10. So for example, here the decimal point would be at the end, and I move it to the left, 3, 4, 5, 6, 7. Now I have a number between 1 and 10. It's 5.6. I determine n by basically determining the number of places moved, which was 7. And it's positive if you go to the left, negative if you go to the right. So since I moved to the left, so basically I took a big number and made it smaller, so that means it's going to be positive. If I start out with a decimal, like 0.00056, and I go to the right to make it 5.6, then that means my exponent is going to be negative. In this case, I went 1, 2, 3, 4, so it's 10 to the negative 4. So a couple of examples here that you can do. So basically here, I moved the decimal 1, 2, 3, 4, 5, 6, 7. So it's 8.2. That's between 1 and 10 times 10 to the 7th. But since it was a decimal, it's going to be negative 7. And I'm going to make, sorry, since it's a negative sign there, it's negative 8.2. Here, start out there, so you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until you get the number that's between 1 and 10. And since it's a large number that you're making smaller, you leave it as a positive. Computations with scientific notation. So basically, here you multiply like terms. So I'd multiply 6.1 times 4. And I'd multiply the power, so 10 to the 5th times 10 to the negative 9th. And the results give me 24.4 times 10 to the negative 4th. Now the problem is, here 24.4 is not in scientific notation. To make it scientific notation, I have to take the decimal point here and move it to the left one space. That makes it 2.44. And when I move it to the left one, I'm going to add a power of 10. So if I go to the left, I'm going to add a power of 10. If I go to the right, I subtract. So basically, by going to the left, I made the larger number smaller. So if I make the number smaller, I add a power of 10, and here it's negative 3. If I go to the right, I would be making a number bigger, and therefore I subtract a power of 10. So for example, here, 1.8 divided by 3 is 0.6. And then when you subtract 4 minus a negative 2 is 10 to the 6th. Now here's an example where it's not between 1 and 10. So to make it between 1 and 10, I move the decimal point to the right one. And if I move it to the right one, that means I subtract 1 here, so I get 10 to the 5th. So notice I took a decimal and I made it a bigger number, therefore I take away a power of 10 there. It's kind of like balancing. If you make one side bigger, you make one side smaller, and vice versa. All right. Square roots. Well, remember, every number has two square roots. There's the principal square root, which is the positive one. That's the one you do in your calculator. The square root of 64 equals 8. There's also the negative square root, and that's where you put a negative sign in front of the square root, and that gives you negative 8. Because think about it, if you square 8 and you square negative 8, both times you get 64. So there are two square roots, the principal one and the negative one. The product rule for square roots, remember, if you take the square root of 8 and multiply it by the square root of 4, that you can multiply them and get the square root of 32. That is possible for square roots. That helps when you're simplifying a square root. When you simplify a square root, you want to find the greatest perfect square factor first. And remember, perfect squares, there's a list: 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the ones you need to know. Find the greatest perfect square factor that goes into 500. That would be 100. And it goes in 5 times. So basically, I simplify and make it the square root of 100 times the square root of 5. So the first step, the greatest perfect square factor is 100. The product rule would mean it's 100 times 5. When I simplify, the square root of 100 is 10. So I'm left with 10 square root 5. The quotient rule for square roots, well, quotient rule means I can split it up into 2 parts. So for example, if I have like the square root of 2/3, I can make that the square root of 2 over the square root of 3. And vice versa, if I have the square root of 6 over the square root of 7, that I can rewrite it as 6/7. So whichever way helps me, I can do that. In this case here, simplifying a quotient, the first thing I would want to do is divide or simplify if I can. Does 6 go into 48? And the answer is yes. It goes in 8 times. X to the third over x, well, by the quotient rule, 3 minus 1 gives me x squared. So I simplified that first. Then I take the square root of 8 and the square root of x squared and simplify them. Well, the square root of 8, the perfect square that goes in is 4, and it goes in twice, so you're left with 2 square root 2. And the square root of x squared is x. So then you're left with 2x outside and the square root of 2 inside. And that is your final answer. Whenever you add or subtract square roots, remember they have to be like terms. So for example, 2 square root 3 and 5 square root 3 are like terms because they both have the square root of 3. So 2 plus 5 would give me 7 square root 3. So here, if I see a sum and they're not like terms, I can always try to see if I can simplify them to make them. For example, the square root of 27 simplifies to 9 and 3. And the square root of 9 is 3. But don't forget this 7 here. You got to bring that down and multiply. So 7 times 3 is 21. Square root of 3. Then the square root of 12 is 4 and 3. And the square root of 4 is 2. So 21 square roots of 3 plus 2 square roots of 3 is 23 square roots of 3. There is a rule where basically you cannot have a square root in the denominator of a fraction. And in order to get rid of that, it is called rationalizing the denominator. And that's where you remove the radical from the denominator. So for example, here to remove it, basically I'd multiply top and bottom by the square root of 6. 15 times the square root of 6 is 15 square root of 6. The square root of 6 times the square root of 6, that gives you the square root of 36, which is just 6. So anytime you multiply a square root by itself, it just removes the square root sign. Now, here's where you have to be careful. That is, you've done everything correct, but these numbers can simplify. The common factor of 6 and 15 is 3. 3 goes into 6 twice, and 3 goes into 15 5 times. So you're left with 5 square root 6 over 2. Whenever you want to rationalize whenever you have a binomial, you have to multiply by what's called the complex conjugate. So in this case, if it's 4 plus the square root of 5, you multiply the top and bottom by 4 minus the square root of 5. So distribute the 8, and you get 32 minus 8 square root 5. And then here, when you multiply 4 plus the square root of 5 and 4 minus the square root of 5, you get 16. And then remember, the whole purpose of multiplying by the conjugate is it will get rid of the middle term, because remember, if you FOIL, you get plus 4 square root 5 minus 4 square root 5. And then the square root of 5 times the square root of 5 is 5, and since it's positive and negative, it's minus. Notice these cancel out. So 16 minus 5 is 11. And you're left with your final answer. One thing you might want to do first before distributing is leave it like this right here to see if maybe this number and the 11 can cancel. If not, then go ahead and distribute, and then you get your final answer there. That might be one thing to do in addition to what I just did. All right, so now talking about cube roots and higher roots, we'll just talk about that. Basically, perfect cubes, like I gave you the list of perfect squares, there are perfect cubes, and there's only a few that you need to know. 8, because 2 to the third is 8. 27, because 3 to the third is 27. 64, because 4 to the third is 64. And 125, because 5 to the third is 125. So same process. What perfect cube goes in evenly to 40? And that would be 8. 8 goes in 5 times. But remember, it's cube root, not square root, and the cube root of 8 is 2. So you get 2 cube root 5. Same thing here if we want to simplify. Here we could do 4th root of 81 over 4th root of 16. Perfect 4th roots. It's 16, because that's 2 to the 4th. And 81, that's 3 to the 4th. Those are the only ones you really need to know. So basically the 4th root of 81 is 3. The 4th root of 16 is 2. That gives you 3 halves. Rational exponents. Anytime you have a fractional exponent, it basically means like a to the power 1 over n means n root of n of a. So basically, like for example, a to the 1/4 would equal the 4th root of a. So if you have a number other than 1, like a to the m over n, basically m is the power of the number and n is the root. So for example, here, 27 to the 4/3, you would have the cube root of 27, not 24, 27 to the 4th power. Now another way you can write that is to write that as the cube root of 27 and then raised to the 4th power. And this helps you to solve it because the cube root of 27 is 3 and 3 to the 4th is 81. Same thing here. This means you have the square root of 9 raised to the 3rd. The square root of 9 is 3. 3 to the 3rd is 27. Here you have the fourth root of 81 raised to the negative third. So here you have 3, that's the fourth root of 81 is 3 to the negative third, which means it's 1 over 3 to the third, which means it's 1 over 27. Something like this, where it's the sixth root of x to the third, you can go backwards and change it into a fraction. So that becomes, remember, it's power over root. So it's x to the third and the sixth root. And then you can simplify the fraction. 3 over 6 is 1/2. And anything to the 1/2 power is the square root of that. That's your final answer. All right, the last thing here we're going to talk about is the different types of numbers. Natural numbers, remember, are whole numbers that are positive, not including 0. So if you look at this list here, you would say 6 and 913 are not natural numbers. Whole numbers are natural numbers including 0. So basically all positive numbers, positive whole numbers including 0 are whole. So basically in this case, you'd have 0, 6, 9, 13. So the only difference between whole and natural numbers is that 0 is included. Integers. These are positive and negative whole numbers. So for example, negative 100, 0, 6 and 9, 13. Remember, fractions are not integers. Rational numbers, any number that is a fraction. That can be written as a fraction. So in this case, negative 100, negative 2/3, because any whole number can be written as a fraction because it's just over 1. 0, 6, 9, 13. Irrational are non-repeating non-terminating decimals. And the only one here is pi. Real numbers, all of these are considered real numbers, so negative 100, negative 2/3, 0, pi, 6, 9, 13. Those are all real numbers. If you have any questions about anything, please come to class with questions. We're going to do some work on this in class. Remember to bring your filled out notes to class because I will check them, and be ready to take a brief 1 or 2 question warm up on this. And that is all. Hope you enjoyed your first day of school.